Hello and welcome. I'm Edwin, a developer on the Cloud Solutions team here at Teradici. In this tutorial video, we'll go through everything step by step so you can get a copy of Teradici's Cloud Access software running in your cloud environment. In this repository, you can choose to deploy in either AWS or GCP. This video will be using AWS. If you'd like to use GCP instead, please check out our other video. We'll be following along closely with our documentation to help flesh out the details to make this deployment as easy as possible. As well, this way, the next time that you need a refresher to use these Terraform scripts, you can simply skip to certain sections of the README file for reference. Aside from the obvious differences such as using AWS console instead of the GCP console for the setup, the Terraform deployment and the Cloud Access Manager portions will actually be quite similar to the GCP video. However, in this video, instead of using the GCP Cloud Shell, we'll be demonstrating the deployment using a native Windows operating system. We'll include and go over instructions on installing Terraform as well. The other notable difference will be the file paths used in our terraform.tfvars file, since the paths are different in a Linux machine versus a Windows one. Let's get started. We'll first need to open up a browser tab and visit the GitHub repository for the cloud deployment scripts. The URL is github.com/teradici/cloud_deployment_scripts. Once you're on this page, if you scroll down a little bit, you'll find an introduction section on the Cloud Access software deployment, as well as links to our documentation for AWS and GCP. Since this is for a AWS deployment, we'll go ahead and click the first option. One thing to note is we'll keep this documentation open as we move through the video, as this way we'll be able to come back and reference certain sections of this README file. If we scroll back up to the top of this README page, we'll find a table of contents with the sections that we'll be covering today. Under the Getting Started section, we'll have a Requirements section, the AWS Setup section, as well as the CAM Setup section. Once we're done setting up, we can then run our Terraform scripts, and this will include steps such as customizing our terraform.tfvars file. The second step here is encrypting our secrets. This is a manual encryption step, which is optional, as this will require the use of Cloud KMS. We do highly recommend using encryption for your deployments. However, for the purposes of this demo, we'll be keeping it simple and just using the plain text deployment. Next, we'll be actually creating the deployment itself using Terraform. And once that's done, we'll be adding these workstations in CAM, so that way we can connect to them using the PC over IP client. And finally, we'll be showing you how we can change the deployment if we want to, and the proper cleanup that we need to do once we're all done. In the third section, we have a section on the architectures of the three different deployment types that we have for AWS. The first one is the single connector deployment. The second is the load balancer connectors. And the third one is the load balancer connectors with the local licensing server. The last section in our README file is troubleshooting. If you encounter any issues when connecting to your VMs, you can definitely check out this section for more information. We include information such as connecting to your Windows VM using RDP or Linux-based VMs using SSH. Before we dive right into the requirements section, I do just want to quickly go over our architecture section for the single connector, as this will be the deployment we'll be doing today. So if we click on it, we'll find more information on the subnets that we create, the firewall rules, as well as the workstations that we provision. If we scroll down a little bit as well, we'll find a diagram of the deployment, and as this will help us visualize it better. Here, the green box is our virtual private cloud, and within it, you'll find the workstations that we provision, the domain controller, as well as the cloud access connector. We also provision the subnets, and so there are three private subnets that we create. In this first private subnet, this is the subnet CAC, and this is where the Cloud Access Connector goes. This acts as the endpoint where our clients connect, and they also act as a gateway to these workstations here. The second subnet is subnet DC. This is where we'll create a Windows-based VM to serve as the domain controller that runs the Active Directory service. Our remote workstations will join the domain here. The third subnet is subnet WS, which is where the workstations will be created, and these are isolated from the public internet. However, they still have internet access as we use a NAT gateway that's configured and set up for these workstations to use. Firewalls are also created to allow wide open access within our VPC, and the selected ports are open to the public for operation and debugging purposes. So one thing to note is for our subnet DC, and we do mention that while ideally it is in a private subnet, we do make it public to provide progress feedback during the Terraform deployment process. This way we know exactly where we are in the deployment process, and also for the ease of access for debugging purposes. 2 domain admin accounts are also set up in the new domain. The first account is the administrator account, and the second is the cam_admin account. And this is the account we'll be using in CAM as well. Domain users are also created if we specify them in the domain users list CSV file, and we'll be using that today as well. And finally, for the Cloud Access Connector, as part of its provisioning script, so once it's created, it will register itself with the CAM service using the given CAM deployment service account that we'll be creating later in this video, as well as the PC/IP registration code. If we scroll back up to the top of this page, we'll find a section on requirements. Here we'll find a set of required items for us to use these Terraform scripts. The first item here is that the user must have administrator permissions in an AWS account. This is required for Terraform to make its deployment with. In the future, we'll be updating this section with a set of least privileged permissions to enforce better IAM security practices. The second item is a PC/IP registration code from TerraDG. If you don't have one, please contact our sales team, or you can purchase a subscription using the link we've provided here. The next item here is the Cloud Access Manager Deployment Service account. We'll have a whole section dedicated to setting up Cloud Access Manager below. The next item is the PC/IP license server activation code. Please note this is only required for the LLS-based deployments and will not be using it today. The next item here is the SSH Private Public Key Pair Setup. We have a whole page dedicated to this, and we'll also be going through this together to set up a private public key pair on the Windows machine. If SSL is involved, the SSL key and certificate files are needed in PM format. For the simplicity of this demo, we'll not be using the SSL today, so we can skip this item as well. For the last item here, we do require Terraform, as that's the tool we'll be using to make our deployment with. Terraform version 0.12 is required or higher, and we'll be going through this as well on the Terraform installation, and we can download Terraform using the link we've provided here. We're now ready to move on to the AWS Setup section. One thing to note is that while it is possible to create deployments in existing and currently in use accounts, we do highly recommend creating them in new accounts, as this way it reduces the chance of name collisions as well as the interference with operations of existing resources. So we'll be creating a new AWS account. So let's head over to a new browser tab, and we'll enter aws.amazon.com/console. And top right here, we'll have an orange button that says sign in to the console. So we'll click on that. Here I already have my account information set up, and I'll just be clicking the login or sign in button here. Once we're signed in, we can type in the service that we want is IAM. We'll click into the IAM page. What we want to do is create a new user, so we'll on the left navigation menu here, we'll click on Users, and we'll click on Add User. So we can create a new one, and we'll be calling this something like Cloud Deployment Scripts. We'll need to give this programmatic access, and that will be used by Terraform. And we'll click on Next. Here we can attach the policies that we talked about earlier. So what we can do is attach existing policy. So we'll click on this tab here. And what we want to search for is actually going to be the first item here. So we can actually just check this off, Administrator Access, and we'll hit Next. Here we'll just hit next for review again. And finally, we'll just hit create user. Once that's done, you should see a success message, as well as the access key ID and the secret access key. Do note, your access key ID is basically like a username, and your secret access key is basically like a password to this account you've just created. With our credentials created, we'll now need to extract these values and put them in a text file. If we refer back to our README file, we'll have instructions on how to do this. Here we have the format of the AWS credentials file that we'll need to create for Terraform to use. So what we'll actually do is go ahead and copy this. And I'll just minimize my browser. On my desktop, I'll be creating a new text document. And we'll name this something like AWS credentials. And then we'll just paste in the format of the credentials file from the README file that we've just copied from. And then here we'll need to replace the value of the ID with the access key ID and the key value with the secret key ID, with the secret access key. So going back to our AWS IAM console, we'll find our access key ID here. So we'll go ahead and copy this value, and we'll paste this in here. Going back to this, and we'll show the secret key now, and then we can copy this and paste it in, and we'll save this file. Alright, and now we have a AWS credentials file that's ready to be used by Terraform. We'll finish off the AWS Setup section by subscribing to the required AMI images. This is required if the workstations that we're deploying are CentOS Standard or CentOS Graphics. We've provided a link here, so we can right-click the link and open it in a new tab. With the page opened, in the top right corner, we should have a button that says Continue to Subscribe. So we'll need to click on this. Once we're subscribed, we should see a message here that says you're subscribed to this software, and then you can also see the terms and the pricing details just below. Just one final note here for the AWS Setup section is we recommend creating a AWS KMS key. This is used to encrypt secrets in the terraform.tfvars file. To keep this video straightforward, we'll not be using the encrypted option today. In the future, we highly recommend creating a key so that you can use it to encrypt the secrets in your terraform.tfvars file. If you scroll down a little bit down here, we have a section here dedicated to encrypting your secrets. So for future deployments, you can definitely read through this section. However, we will not be covering it in this video. We're now ready to move on to the next setup section, which is for Cloud Access Manager. We'll first log into the Cloud Access Manager admin console by using the link we've provided here. We'll first create a new deployment using the PCoIP registration code. Once the deployment is created, we'll create a service account for that deployment. And then finally, we'll download the JSON file, which will be the credentials file for this deployment service account. This deployment service account credentials file will then be used in the terraform.tfvars file. Let's go ahead and right-click on this link and open the link in a new tab. We'll sign in with a Microsoft Business account. Once we're signed in, we'll be brought to the dashboard page. And up top here, you can see the deployment that you're in. We're currently in a default deployment, so we will want to create a new deployment for this. So we'll create deployment. We'll enter a deployment name. I'll be calling mine Cloud Deployment Scripts. We'll need to also enter our PCoIP registration code. I already have mine, so I will go ahead and paste this in. And here we can just ignore the cloud credentials for now. With the deployment created, we can head over to the Cloud Service Accounts page. On this page, we can add an AWS Service Account credentials, which will then be used by CAM to interact directly with the remote workstations that we've provisioned using Terraform. This will give us features such as power management, as well as the ability to provision new remote workstations using CAM. If we click on the AWS button here, we'll see that we can generate a role for AWS, and then we can add this role to CAM. To keep things simple for this demo, we'll not be adding a role to CAM, but if you want to learn more, you can read about it here. Next, we'll create and download the deployment service account, which will be used by Terraform. If we click on this page and click on the plus icon, this will create a new deployment service account that's tied to the cloud deployment scripts deployment. With the account created, we have the option to download the JSON file, so let's go ahead and do that. Once that's downloaded, we can open this up in our downloads folder, and since we're keeping our credentials file on the desktop, just for this demo, we'll go ahead and actually copy this and place it in our desktop as well. Great, now we have the service account created. We can open up a new browser tab for the SSH Key Pair Setup page. On this page, we'll find a link to download PuttyGen, which is the utility tool we'll be using to generate our key pair on a Windows machine. If we click on this, we can open up the link in a new tab. And if we scroll down a little bit, we'll find the download link to our system, which is a 64-bit window installer right here. So we'll go ahead and download this file. Once it's downloaded, we can run the installer. And we'll just follow the on-screen prompts here. We'll click Next, Next, and Next. We can skip viewing the README file and just click Finish. With the installation completed, we can open up our Start menu, and under Putty, we'll find a utility tool called PuttyGen. This is what we'll use to generate our key pair. Here we want to make sure that the type of key to generate is RSA, and then we'll click on Generate. Here we'll just move our mouse around, and we'll wait until the key is generated. What we want to do next is save both the public key and the private key. Note that the public key can be thought of as like a username. This is the key that will actually upload to our Linux machines, and this is the file that we'll also put in our terraform.tfvars file in the next section. Your private key is what allows you to be authenticated using SSH. Can be almost thought of as like a password, so you definitely don't want to be sharing this key with anyone or lose it, as you will not gain access to those VMs that you've provisioned. So let's go ahead and save our public key. Just for ease of access, I'll be putting it on the desktop here. And I'll be naming the file id_rsa.pub. .pub will just help me remember that this is the public file. Then we'll save the private key. And it will ask you if you want to save this key with other passphrase, and we'll just select yes. We can just call this idrsa.prv. And now on the desktop, you should see two files. One is your private key, and your other one is the public key. So this way you won't mix it up, and the one we'll be uploading to Terraform will be the idrsa.pub, and then the private key is what we'll use if we want to use SSH to gain access to those VMs we've created. The use of SSH will not be covered, as it is outside the scope of this video. However, if we go back to our browser tab and open up our README file here, if we scroll down all the way to the bottom, our last section will have something called Troubleshooting. If we click on this page, you'll find more information and instructions on using SSH to connect to your VMs, mostly for debugging purposes. You'll find some commands here that you can use, as well as down below you'll find the login users that you'll need to use for each of the Linux VMs. We can now move on to the last requirement, which is installing Terraform. Terraform version at least 0.12 is required. At the time of this recording, 0.13 has been released, and we can download Terraform using the link we've provided here. We can right-click and open this in a new tab. Once we're on the Terraform download page, we can scroll down until we find the operating system we're on, which is a 64-bit Windows, and we'll click on this, and the download should start. And we'll open up our downloads folder, and what we'll do is actually extract this and go to extract all and extract. This will unzip our file, and open up a folder with our Terraform binary in it. What we'll now need to do is set up a system path, so that way every time we use Terraform we don't have to use the full path of the Terraform binary. So what we'll do next is copy our Terraform binary file. What I like to do is create a folder under Program Files, and we'll create another folder here called Terraform. Doesn't matter what you call it as long as you can find it, but I like to stay organized, so we'll go with Terraform. And then what we can do is just paste in our file here. Once we're here under My PC and Properties, we can go to the Advanced Settings. And once you have this window open, you should see Environment Variables towards the bottom here. And we'll click on that. And what we'll want to do is edit our system path and go New. And then we'll browse for that binary file that we paste inside the Program Files folder. So we'll find our Terraform folder here, and we'll click OK. And then OK and OK. What we'll do next is we'll test our Terraform command by opening up a PowerShell terminal. So using the Start menu under PowerShell, we can now type in the command terraform-v. And if we see that the version returns something, that means that we've done this correctly and Terraform is ready to be used. With all the requirements completed, we can now move on to customize our terraform.tfvars. Terraform.tfvars is a file in which we can use to specify variables for the deployment that we're doing. For each of the available deployment types, there is actually a sample file which will serve as a reference for you to use. And in this sample file, it has the required variables that we must provide, along with other commonly used but also optional variables. And here it goes on to describe that the uncommented lines, which is just a regular line, will show the required variables, while the commented lines, which is represented by a hash symbol as the first character, this will show the optional variables with the default or sample values that will be used for the deployment. A complete list of all the available variables can also be found in a file vars.tf of that deployment. One important note here when customizing our terraform.tfvars is for these path variables, these must be absolute, and the format depends on the host platform. So what we mean by this is on Linux system, the / is used as the default path segment separator. So the path looks something like this on a Linux machine. However, on Windows, oftentimes you'll see the drive letter followed by a / separator. So since we're on the Windows machine, what we do need to do is instead of having backslashes for our path separator, we'll have to change this to the /. And we'll go through an example of filling out the terraform.tfvars together. We'll first need to download the repository into our local system. If you have Git installed, you can simply just git clone it into a directory. Since it doesn't come normally installed on a Windows machine, what we'll do is go to our repo here. This is the terradg/cloud deployment scripts. We can just press on this green button and we can just click on download zip. What this will do is just download a zip file, and once again we can just extract this. Once extracted, I will simply just copy this and put it on our desktop. With the repo cloned and downloaded, we can now open up the folder and navigate under Deployments, select AWS, and Single Connector, as that's the deployment we'll be using. Once we're inside, we'll find that there's a file called terraform.tfvars.sample. This is a sample file for all the variables that are commonly used and can be configured for your Terraform deployment. Note that for each of the other deployments, there is a separate terraform.tfvars.sample file that you can use as well. And what I like to do is leave this as a reference file, as if you do make a mistake or want to reset your configuration file, you can simply delete the old terraform.tfvars and just refill out a new copy of this file. So what we'll do now is copy this and just paste it into the same folder. and we'll have to rename this and just by deleting the .sample in the copy here. We'll just click on yes. And now we have our terraform.tfvars file that would actually be used by the Terraform deployment. We can begin editing the settings by right-clicking on this, and we'll just open with a text editor such as Notepad. We're now ready to fill out our terraform.tfvars. I'll be going through this file from the beginning to the end, and I'll do my best to explain all the different optional and the required variables as we move along. The first line in this file here indicates that commented outlines represent defaults that can be changed. So for example, for some of the variables you see here, the hash symbol indicates that this is an optional variable. However, it also indicates that what the default will be if this is not changed. On the other hand, we have required variables such as the AWS credentials file here. You'll notice that there is no hash symbol in front of this variable name, which means that this is required for us to fill out, and that the deployment wouldn't work if we don't fill out these required variables. And the second item here to keep in mind when filling out the TFVars file is that when dealing with path variables, such as the path to the AWS credentials file, we'll want to make sure that the default Windows / path separator is changed to the /. So for example, if we right-click our AWS credentials file, you'll see that by default, the path uses a / here, and that is just a default Windows /. For the configuration file to work, these backslashes do have to be changed to the /, and this is just a note indicating that. So let's continue and fill out our first required variable here, which is the AWS credentials file. Under the file properties, we already have the details tab open, and you can see the folder path to this file. And what we can do is we can just put that path here. We'll type in C:, and do have to remember to change it to the /. So that's what we'll use here. We'll type in our path name as indicated on the details line here. And then we'll also use the file name here. And we want to make sure that we have the full file name, including the .txt, which is enforced in Windows. So we'll go AWS credentials.txt. For this next variable, it is optional as indicated by the hash symbol in front. This will be for the AWS region that we want to create our deployment in. By default, the deployment will be creating in the region US West 1. So if we want to change this to a different region, all we need to do is delete the comment, and we can change this region to whatever we want, such as US West 2. For this demo, I'll just be using the default value, which is US West 1. For the next variable, prefix, this is a prefix name that is added to all the resources names by Terraform. It is limited to a max of 5 characters to avoid the cropping of our workstation host names. This option is highly recommended as it does reduce the chance of any name collisions in your cloud environment. So to use this, what we can do is simply delete our comment, and then we'll put in something unique such as an initial and with a number, and I'll call mine EP3. And that way it is also easily identifiable which VMs belong to which deployment. For this next variable, this is the allowed admin CIDRs. So by default, the VPC firewall is set up to only allow Terraform host to connect using ICMP, SSH, RDP, or WinRM. So if we want to open up the firewall to additional IP addresses, all we need to do is add the IP address with the CIDR here, separated by comma. So we'll be leaving this value as default, which means we can only access our provisioned VMs using the Terraform host. For the next variable, it is optional, and this is for the allowed client CIDRs. So by default, PC over IP clients are allowed to connect from any IP addresses indicated by 0.0.0.0/0. If we want to place additional restrictions on which IP addresses can connect from the PC over IP clients to our remote workstations, then we would simply add those IP addresses here Here's an example separated by a comma. So we'll be leaving it as the default, which is allowable from any IP. For this next variable, it's for the domain name. We can just use the default value here for the demo, which is example.com, and I'll be leaving this commented out. For this next one, this is where we can add additional Active Directory users for our Terraform scripts to create. If we head into our cloud deployment scripts, deployments, under AWS and single connector once again, you'll see that there's a file called domain users list.csv. So this is the file where we can indicate and list additional Active Directory users to create. In our GCP demo, we actually have a section showing how we can use this file to create the additional users. So if you would like to use that option, please refer to the other video. Moving on to the next one here, this is where we can specify some optional variables and configuration for the CAC, which is the connector, such as the instance type, the disk type, and some AMI settings. If we go down a little bit here, this is the SSL key and the certificate. For the purposes of this demo, we'll just be using the default and will not be specifying a SSL certificate for the connector. For our next variable, this is the admin SSH pub key file. This is where we would indicate the path to the public key file that we created earlier in the video. If we look on our desktop, we have the public key and the private key, and we'll need to be sure that we're using the .pub file. So we'll click on this and right-click for properties. And here, under details, we can find the folder path. So we'll use C:. We'll once again need to change the backslash to a /. And we'll type in the folder path first. And then we'll also indicate the file name, which is /id_rsa.pub. With the key filled out, we can now specify the number of workstations we want to deploy. And as you can see here, there are some optional variables for each of these workstations if you want to choose to change, for example, the image that it uses, the owner, the disk size, as well as the instance type. For now, we'll just leave these as the default values. However, we will change the number of workstations we'll deploy. So we'll deploy 1 Windows Graphics, and we'll deploy 1 standard CentOS. And here's a reminder that we do need to subscribe to the AMI images, which we've already done. So we can now move on to the secrets section. So here in the secrets section, we have a optional variable here called customer master key ID. So if you refer back to earlier in this video, we've talked about creating the crypto key on AWS KMS. And this is where you would specify the key that you've used to encrypt those secrets. So for more information, once again, just refer back to that optional section in the README file, and it will talk about how to use this variable. So we'll finish off this section by filling out the secrets. So here we have to specify a password for the domain controller, a safe mode admin, and the Active Directory service account password. So the user cam admin will be tied to this password that we create here. So whatever you put in for your secure password, be sure that you can remember it. And here we have our PC over IP registration code, and I'll just copy mine in. For the last variable, we'll need to put in the path for the cam deployment service account file. So we can open up properties once again, and here we'll find the folder path. So let's go ahead and put that in, and we'll be sure to change our backslashes to /s once again. Administrator / desktop. Then we'll put in the file name and just copy this in. And once we're done, just be sure to save the file. We're now ready to move on to the next section, which is creating our Terraform deployment. This is probably one of the easier steps in the tutorial, as we only have to run the 2 commands terraform init and terraform apply, and our scripts will do the rest. We'll first open up a PowerShell terminal. And we'll first need to change the directory to the one where our TFVars is. So we're currently in users/administrator. We can use the command ls to see the directories that are available to us. And we'll want to navigate into the desktop, so we'll use the command cd, which stands for changing directory to desktop. And here we can see that our repository cloud deployment scripts -master is in here. So we'll once again use cd cloud_deployment. And here we can just hit tab for the auto completion. And once again, we'll hit ls. What we want to navigate into is deployments directory. And next we'll want to select AWS and into the single connector deployment. If we do another ls here, we'll see that we have the terraform.tfvars file that we've just saved, and that's the directory that we want to be in. We can now run the command terraform init. What this will do is it will install the required modules as well as the provider plugins. Once it's been initialized, we should see this green message here that says Terraform has been successfully initialized. So once we see this message, we can use the next command. But before we actually use Terraform apply, there's an extra command that we can use, which is called Terraform plan. What this will do is check that the terraform.tfvars file has been filled out correctly and that there are no other errors before we actually commit to a Terraform apply. So this is a good way to make sure that we don't run into any errors when we do the apply. So it is usually recommended to run the plan before we actually run apply. So we can see that the plan has successfully executed without any error messages, and it says 44 to add. So this way we have more confidence that our Terraform apply will work. So now we can go Terraform apply. And this will actually begin our deployment process, creating all the resources in the AWS cloud. It will ask us to confirm, and we'll have to answer yes to confirm. So we'll wait for it to scroll all the way down, and we'll type in yes and press enter. Please note this process may take up to 15 to 30 minutes. So we'll come back once it's done, and you'll know once it's done once you see a green output message on your console. With our deployment complete, we now see a green output message on the console. This output contains the IP addresses of the VMs we've just provisioned using Terraform. For example, we have the public and the internal IP of the connector here, CAC internal and CAC public. We also have the internal and the public IP of our domain controller down here. Finally, we have the IPs of the CentOS and the Windows workstations. Do note once again that since workstations are placed inside a private subnet in the VPC, they're not directly exposed to the internet this way and will only have the internal IP. However, they still have access to the internet through a NAT gateway we've created and configured using our Terraform scripts. Going back to our documentation, we can now see that we've finished with the creating the deployment section, and we can move on to the next step, which is adding the workstations in Cloud Access Manager. We'll go into CAM Admin Console and add the newly created workstations to CAM. We'll also be assigning the user entitlements for these workstations so we can connect to them using the PC over IP client. We'll head back over to the CAM Browser tab. We'll first make sure that we're in the correct deployment by clicking on this drop-down menu. And we want to select Cloud Deployment Scripts, which is the deployment we've created earlier in the video. Once we're in here, we can click on Connectors. And here we'll see the single connector that we've created using our Terraform scripts. We should also see a health check as well as the IP addresses, and these IP addresses should match up with the console output that you see. One thing to note here is if your deployment just finished, the health check here may be unhealthy, and that's only because the state is not immediately synced up. If we wait a little longer, this should appear healthy. We can now head over to the Workstations tab where we can add our remote workstations that were provisioned using our Terraform scripts. If we click on the plus icon here, we'll have an option to add an existing workstation. You'll see that a second option to create a new remote workstation is grayed out, and that's because we didn't add our cloud AWS credentials. So if you like to use power management options or have the ability to provision new machines using CAM, please go through the process to add the AWS credentials to CAM. So we'll go ahead and click on Add Existing Remote Workstation. And here for the provider, we'll select our private cloud. And here we can see that we've added our workstations, and we can select the graphics windows as well as the standard CentOS. And here we'll list the user entitlements for the workstations that we have up here. And we'll be selecting CAM admin, and we'll hit save. With our workstations now added to CAM, we can now begin the next section, which is starting our PC over IP session. We'll be using a PC over IP client to connect to our connector, and then we'll be selecting the workstation that we want to connect to. We'll first need to download the PC over IP client. If we head back over to our Terraform webpage, under Products and under PC over IP client, we'll find a link here if we scroll down for software clients and mobile clients. We'll hit on View Downloads. Here we'll find the different software clients for different operating systems. Since we're on Windows, we'll be selecting the first option. And here we'll find a link to download as well as a link to an administrator guide if you require more assistance. So we'll click on Download. And we'll scroll down and agree and download. With the client downloaded, we'll now install the client. We'll select English, and we'll just hit Next, Agree, and Install. This process is relatively simple, and once it's downloaded and installed, we should be able to just open it up and use it. Great, we'll create a desktop shortcut, and we'll be using that. And here we can open up our PC over IP client once it's installed. To connect to our workstations, we'll need to enter the external IP of the connector that we've provisioned. We can find that information in the green output screen here on the right, as well as in CAM under the Connectors tab. We'll need to copy the IP address of the external IP of the connector here, and we'll paste that in. And here we may get a message that says we'll be connecting insecurely, and that's because we didn't use the SSL certificate in our terraform.tfvars file. So we'll just go ahead and hit connect insecurely. For the username, we'll be using cam_admin. And for the password, we can find that information by going back to our Terraform deployment directory, single connector. And if we refer back to our TFVars file, we can find that under the secrets section. And this will be the AD service account password that you've specified in your terraform.tfvars. So once you find that password, we'll be entering that in here, hitting login. Great, looks like we're logged in. And now we should see the two workstations that we've added to our CAM admin user. We'll first connect to our Windows graphics workstation. So one thing to note here is when we're connecting to our workstations right after the deployment is finished, sometimes there may be a message that comes up saying that the remote desktop is restarting. When this happens, it just means that the machines are still being provisioned, so we'll just have to wait a few minutes or reconnect if it times out. And here it looks like we're able to get in. What we can also do is just drag the window to make it a little bit bigger to work with, as well as the option to full size for a better viewing experience. And here we can check that this VM does have internet access. If we open up Internet Explorer, we can type in a web page such as terraform.com. We may get some security warnings just by default. That's just how Internet Explorer works. And great, looks like we're able to connect. We can also check out the other machine, which is our CentOS. And we'll relog in using the same IP address, using the same credentials. And we can select standard CentOS. And great, looks like we're able to get into our CentOS machine as well. Feel free to pause the video at this time to explore the remote workstations further. This way you can experience our high definition and highly responsive remote workstations firsthand. When you come back, we'll finish the demo video by showing you how we can change our deployment. And finally, we'll go through the teardown process and clean up all our cloud resources. Up next, we'll be changing our Terraform deployment. So Terraform is a declarative language used to describe our desired state of resources. What this means is we can actually modify our terraform.tfvars file after the first time that it's been deployed, and we can run the same command terraform apply again. So Terraform will only try to make the necessary changes to achieve this new state. So we can actually use this method to provision new machines as well as remove machines that we no longer need. Now, one thing to note is if we are deleting workstations using the Terraform scripts, then we would have to do two things, because CAM doesn't know about the state of the resources that were removed manually by Terraform. So we would have to go into CAM and manually remove the entry for the workstation. The second thing is we'll also have to go into our Windows domain controller and remove the computer object. Our Terraform scripts will take care of joining the domain for the workstation, but it doesn't handle the unjoining domain on deletion. We'll first minimize our browser tab here. We'll navigate into our Cloud Deployment Scripts folder. Under Deployments, AWS, and Single Connector, this is where we can find our terraform.tfvars file again. This is what we filled out earlier in the video, and we'll see that we've only deployed a Windows graphics as well as a standard CentOS workstation. If we want to add additional workstations, all we have to do is change the number here to 1 to add an additional Windows standard machine, and here we can also change this to 1 to add an additional CentOS graphics machine. So let's go ahead and save our file. Back over in our PowerShell terminal, all we need to do now is rerun the command terraform apply. It'll take a couple seconds here to load, and it should prompt us to confirm by typing yes and hitting enter. And we can see that Terraform is now deploying the extra workstations that we've added in the terraform.tfvars. We'll open back up our browser and head over to the AWS Management Console. Under the EC2 and instances, we can find a list of all the VMs we've provisioned. My list will look different, as I do have another deployment. That's also another reason we should use the prefix, as it's a great option to separate your resources. And here you'll see that 2 additional VMs are created, which are the 2 workstations that we've just added to Terraform. And you'll see their state is initializing. And back over on our output, we'll see that the resources have been created and their IP addresses are shown in the output. Now keep in mind the provisioning process may take up to 10 minutes for each of the workstations, so before we add it to CAM, we'll have to wait a little bit. After waiting about 10 minutes, we can now head back into CAM, and under Workstations, we can add an existing remote workstation. We'll select our private cloud as the provider, and here we'll see that the Windows workstation and the graphics CentOS are now on our list, and we can Once again, just like what we did before, select the user, which is CAM admin, as the user entitlement for these workstations. And we'll click on Save. If we now go back and connect using our PC over IP client, and we'll paste in the IP address, click on Next, and we'll connect in securely. We'll type in the default admin account that we used with the 80 service account password and log in. We'll now see that we have all 4 workstations added. We can also use this method to remove workstations from our deployment. If we go back out to our terraform.tfvars, what we can do is change all the workstations here to 0. And we'll hit save. With the file saved, we can go back to our PowerShell terminal, and once again we'll use the same command, terraform apply. And once again, it will prompt us to enter yes again. Just wait for it to scroll all the way down, and then we'll type in yes and press enter. What this will do now is Terraform will remove the workstations that we've asked in terraform.tfvars. So if we go back to our browser page, we can actually go back into our EC2 instances page, and if we refresh this, we can see that our instances for the graphics Windows and here graphics CentOS, they're being terminated, and we also have a couple other ones that are already terminated. And don't forget, if we are removing workstations this way, since CAM doesn't know about the Terraform states, what we do need to do is going into CAM, and under workstations, we will have to remove the workstations we've just deleted. And then we'll also hit delete. And the final thing, which will not be shown in this video, is removing the computer object from the domain controller. It is outside the scope of this tutorial, but don't forget, for a proper full cleanup, we will have to go into the domain controller to remove those computer objects that represent these workstations. We'll finish off our tutorial here by deleting our Terraform deployment. We'll be using the command Terraform Destroy to remove all the cloud resources that were provisioned using our Terraform scripts. So we'll go ahead and minimize this. Back over in our PowerShell terminal, we'll type in the command Terraform Destroy. If we wait a couple of seconds here, it'll also prompt us to enter yes. Keep in mind the destroy process may take up to about 5 minutes. So we'll come back once the destroy process is done, and then we can delete the entries in the Cloud Access Manager. So we'll type yes here. With the Terraform Destroy completed, we can now go back to our browser and into Cloud Access Manager. For our deployment, cloud deployment scripts, we'll want to click the menu here and hit Delete Deployment, and we'll enter OK. With that deleted, we've now cleaned up our Terraform deployment. And that concludes our tutorial on the AWS single connector deployment. If we head back over to our README file, this last section here will contain a link to a troubleshooting page. If you encounter any issues while doing your Terraform scripts deployment, you can refer to this page for more information on connecting to your problematic instances using SSH for the Linux machines, or the Windows workstations using RDP. We also provide the important log locations such as system logs and provisioning logs for each of the VMs. If security issues or bugs are found, or perhaps you have feature requests, please contact Sherman Yin, who is the maintainer of this repo, at syin@terradici.com. Thank you for watching.